This standard is about simplifying radicals. We'll start off simplifying radicals that just have numbers in them, then we'll do some with variables, then we'll do some arithmetic, adding, subtracting, and multiplying. So, here's some radicals with numbers in them. When you see a radical, what you should do is take the square root of the number inside. And there's no real arithmetic way to do that. The only way to do that is by knowing in your head what two numbers multiplied together that are the same will give you 49. And the square root of 49 is 7, because 7 times 7 is 49. What we mean here with this radical sign is that we're only looking for the positive root, because also, you know, negative 7 times negative 7 would be 49, but if you just see a plain old radical, all we want to see is the positive one. If we're looking for the negative root, math people put a negative in front of the square root, so the square root of that is negative 4. 4 times 4 is 16, and the minus in front means you want minus the radical 16, so minus 4. If you've got a negative on the inside, you have a problem, because what I'm needing is two numbers that are exactly the same, and a minus times a minus would give me a plus, not a minus, so there's no way to get two numbers that multiply to give negative 81 that are exactly the same. So this one is undefined. If you do it out on your calculator, you might see it says error or something like that. So now here's some more number ones that don't have an exact answer, but we can do some work to them and simplify them and change them to another way that's often very useful when you're doing math problems. You'll see that you need to do this next year in geometry. So if I have the square root of 200, I don't know two identical numbers that multiply to give 200, but I need to look and see if I have any perfect square factors inside the radical. So numbers that are perfect squares. Gosh, let's make a list over here on the side. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 16, 25, 36, 49, 64, 81, and 100. We'll stop there. So, are any of these numbers factors of this first one? Several of them are, but it's always good to pick the biggest one. So, let's go with 100, because 2 times 100 is 200. So I'm going to rewrite this as 2 times 100. And then you take the square root of whatever factors you can. I can't take the square root of 2, but I can take the square root of 100. It's 10. So that goes outside the radical because you've already done the rad bit with it. And the 2 stays inside. So if you want to simplify a number, you need to look for all the perfect square factors it has inside and take them out. So the square root of 75, let's look through my list here. 25 is the biggest one that goes into there. So this is the square root of 3 times 25. Square root of 25 is 5, so that comes outside. And what's left inside is 3. The square root of 48. So let's go down the list here. 4 does go into it, but there is a bigger one. But let's just say you started with 4. What would happen there? 4 times what is 48? That's 12. So square root of 4 times 12. Take the square root of 4, bring it outside, that's 2. And the thing you notice here is you're not quite done, because 12 also has a perfect square factor. 12 is the same as 4 times 3. Square root of 4 is 2, so you bring that outside, so you have 2 times 2 times the square root of 3, or 4 times the square root of 3. So a way you could have gotten there quicker is if you're good with numbers, you also notice that 16 goes into that one. 3 times 16 is 48, and then the square root of 16 is 4, so you'd get to the exact same thing in fewer steps if you did it that way. So you could have written it as the square root of 16 times 3, and that would have given you 4 rad 3 right away. So it's best to pick the biggest one so there's fewer steps, but if you pick a smaller one, you'll get there eventually. Here's some with variables inside. This is a little bit trickier. I'm looking for two identical things that are going to multiply to give me x to the 10th. Remember when you're multiplying exponents, what you do is add the powers. So really what I'm looking for is two identical numbers that would add up to 10. So basically what you do is you take the 10 and divide it by 2. 10 divided by 2 is 5, so this is the square root of x to the 5th times x to the 5th. So the square root of x to the 5th times x to the 5th is just x to the 5th. The square root of x to the 3rd, this one, if you divide 3 by 2, you get 3 halves. And in Algebra 2, you'll see that's not necessarily a horrible answer. But we're going to do this just with exponents that aren't fractions. So what I need to do here is look for a perfect square factor. And for a perfect square of a square root, you need an even number, because then you can divide it by 2 and get a regular old number. So I'm going to turn this into the square root of x squared times x. I've taken out a perfect square factor by taking out the biggest even exponent I possibly can. And the square root of x squared is just going to be x, because x times x is x squared. And then the x stays on the inside. Sometimes these show up with more than one variable. So y to the 12th, that's cool, that's an even number. But this one is an odd number, so I'm going to have to turn it into the square root of x to the 4th times x, and then the y to the 12th. So let's go through and take the square root of all of these. To get this one, I'm going to have to divide by 2, because 2 plus 2 would be 4. So that's x squared. The x I can't do anything with, so that stays inside the rad. And then y to the 12th, divide that by 2, you get y to the 6th, so that's going to go out here. So my final answer is x to the 2nd, y to the 6th, and what stays inside is the square root of x. Let's do another one that's got a number in it. So let's see, first I think I'll put everything inside in terms of perfect square factors. So 8, the biggest perfect square factor of 8 is 4. So that's going to be 4 times 2. X to the 6th, that's an even number, so I'm going to be able to take its square root. I'll just divide by 2. Y to the 9th, that's not even, so I'm going to have to turn that into y to the 8th with 1 y left over. So let's put everything outside the rad. I can take the square root of. The square root of 4 is 2. I'm going to cross out the ones I did. 2 I can't do anything with. The square root of x to the 6th, divide 6 by 2 and you get 3. So I'm going to put x to the 3rd out here. Divide 8 by 2, you get 4. Y to the 4th goes out there. And what's left inside that I couldn't take the square root of is the 2 and the y. Besides taking square roots, you can also take cube roots. When you're taking the cube root, you're looking for 3 identical numbers that multiply to give the number. So 27, and same deal, you just have to know them. There's no arithmetic way to figure them out. So 3 times 3 is 9, times another 3 is 27. So the cube root of 27 is 3. Now I need 3 things that are going to multiply together to give me x to the 6th that are all the same. Let's do a little scratch work over here. That's going to be x to the 2nd times x to the 2nd times x to the 2nd, right? All 3 of those are the same, and 2 plus 2 plus 2 is 6. So I think you can see you're dividing the 6 up into 3 parts that are all the same, so that's the same as doing 6 divided by 3, and that's going to be x to the 2nd. So if you're taking the cube root of an exponent, you need to divide the power by 3. Next, we're going to add radicals. The trick here is to only add like terms, and by like terms, I mean terms that have the exact same rad in them. So this is 3 rad 5 plus 6 rad 5. That means I have a total of 9 rad 5s. It's just like adding x's. Here, let's look for stuff that's the same. So I've got a rad 5x and a rad 5x. So I can combine those two together. So 2 of them minus 5 of them is going to give me negative 3 of them. Now let's see about these things. Rad 7, rad 28. It looks like I can't do anything with that, but let's keep going. Clearly rad 7, I'm done. But 28 does have a perfect square factor. That's 4 times 7. So we're going to write this as 3 times the square root of 4 times 7. So let's just write everything over again because we're all organized here. The square root of 4 is 2, so I'm going to bring 2 outside the rad. All right, 3 times 2 is 6. Now I'm ready for my final step. I have minus 1 rad 7 plus 6 rad 7. Minus 1 and 6 combine to give 5. So my final answer is minus 3 rad 5x plus 5 rad 7. Last, we're going to multiply radicals. To do that, you just multiply the numbers that are inside. So 3 times 6 is 18. That's the square root of 18. Whenever you get an answer, you need to look and see if there's any perfect square factors in it. 18 is 9 times 2. And the square root of 9 is 3. So the final answer there is 3 rad 2. This one requires combining the FOIL that we did in a previous unit with our radical simplifying skills. So I'm going to multiply the firsts. That's going to give me 2 rad 5 times 3 rad 10. So I'll multiply 2 times 3 to get 6. And then 5 times 10 is 50. Next I'll do the outsides. So 2 rad 5 times negative 4. I'll just multiply 2 times negative 4 to give me minus 8. And then the rad 5 stays. Next I'll do the insides. So there's only one number, 3, minus 3, and then 3 times 10, rad 30. And then the lasts, I have minus rad 3 times minus 4. Minus times a minus is a plus. And then 4 rad 3. Now let's look and see what I can do here. Rad 50, I can simplify that, because 50 is 25 times 2. And 25 has a square root, which is 5. Let's see, let's write all these over again, just to have this look as nice as possible. So the square root of 25 is 5, and then 5 times 6 is 30. So this is 30 rad 2, minus 8 rad 5. Does 30 have any perfect square factors? No. Let's go through and look at all my rads. I have a 2, a 5, a 30, and a 3, so there's nothing to combine, and that is my final answer.